Alright, here we are, part E. We've got this function, 1 minus log to base 5, put that in, of x minus 2. Now the domain is where x minus 2 is greater than 0, so x is greater than 2. Is the domain, and the range, of course, is just any value of y. Okay, part 2. What do we need? Asymptotes and axis intercepts. Well, there is only a vertical asymptote when x minus 2 is equal to 0. So that gives us a vertical asymptote at x equals 2. X-axis intercept, well, that occurs when y equals 0, so that's when y minus log to base 5 of x minus 2 is equal to 0. Rearranging is equal to 1, so x minus 2 is 5 to the 1, so x equals 7 is the x-axis intercept. Y-axis, there is no y-axis intercept. It's a horizontal translation of 2 units to the right. So, and looking at the domain, x is greater than 2, so x can't be 0. So no y-axis intercept. Alright, we've got to sketch this one. Now let's just quickly have a look at what is happening to this. The normal log graph would go like that. This one's got a translation 2 units to the right and a vertical translation of 1 unit up, but it's also got a negative in front of it, which means it's reflected in the x-axis. So our normal graph then would have looked like that, but moving it 2 units to the right and 1 unit up, it should be going to be something like that. Alright, so let's graph this one. First thing, draw in the asymptote at x equals 2. Mark the y-axis intercept at 7. And from before, we know the general shape where it's going. So it's going to be coming down like this. Okay. Alright, finishing off with part 4, we've got to solve for when fx equals minus 1. That gives us this equation, 1 minus the log of x minus 2 equals minus 1. So rearranging, we get log to base 5 of x minus 2 is going to be equal to 2. So we should be getting hopefully used to this process now. So that gives us x minus 2 is 25, giving us x equals 27. So it passes through the point 27 minus 1, which is way up here somewhere. Okay, that finishes part D.